So this video is going to be about completing tables and then using those tables to make a graph. So let's take a look. Here we have our first problem. The ratio of salamanders to frogs is 2:6. Complete the ratio table and then graph it. Right? So they've already kind of set up a ratio table for us. They put salamanders first, frogs underneath that. And you can see that the ratio they gave us was 2:6. All right? So, and you can see the 2 coordinates with the salamanders, the 6 coordinates with the frogs, right? They're just in the same order. And so then they've given me a list of other numbers they want me to graph. All right, so before I can do that, I have to figure out what their values, the values of the frogs would be. I have the values of the salamanders. All right, so let's look. How did they get from 2 to 1? Okay, well, one way to get from 2 to 1 is to divide by 2. So 2 divided by 2 is 1. That means on bottom here, I also need to divide by 2. So 6 divided by 2 is 3. All right? And then, because this is the value for 1, I can use that as my unit rate to get to the rest of these values. All right? So to go from 1 to 3, I'm multiplying by 3. So I do the same thing down here, times 3. 3 times 3 is 9. All right, and then to get to 7, I'm going to go back to 1. 1 times 7 is 7. So 3 times 7 is 21. I go back to 1. 1 times 8 is 8. So 3 times 8 is 24. For 9, I go back to 1. 1 times 9 is 9. So 3 times 9 is 27. And then for this last one, 1 times 12 is 12. So 3 times 12 is 36. All right, so I'm going to use these values now in order to come up with a list of ordered pairs. All right, so I'm going to let salamanders, if I look at my graph down here, I know that the x-axis is my horizontal line down here, and the y-axis is my vertical line right here, right? And I just want to make sure I have the right x and the right y. So salamanders is going to be my x, and frogs are going to be my y. All right, so when I make my ordered pairs, then I'm going to list the x first and then the y. That's why it's called an ordered pair. So for salamanders, the first ordered pair would be 2, 6. The second ordered pair would be 1, 3. The third one would be 3, 9, 7, 21, 8, 24, 9, then 27, and the last one is 12, 36. All right, so I have a list of ordered pairs here. Now I want to take my ordered pairs and put them onto my graph. So I always start from the origin, that's 0, and I go over, right? I go to the left or right. Some people say I have to walk to the elevator before I take it up or down, okay? So I'm going to walk over to 2, and then I'm going to go up to 6, and that's where I'm going to place my point. Then I'm going to do 1, 3. So I'm going to go over to 1 and then up to 3. Well, here they're not labeled individually, so I have to sort of guess where 3 would be. So I have 0 and 6 here, so 3 is going to be halfway in between there. 3, 9, so I'm going to go over to 3 and then up to 9. And again, looks like these are going up by 3, so 6 plus 3 is 9. So 9 would be right there. Then 7, 21, I can go over to 7 and up to 21. So 21 is going to be between 18 and 24. 8, 24, I go over to 8 and then up to 24. For 9, 27, I go from 0 over to 9, then up to 27, which has to be between 24 and 30. And my last ordered pair is 12, 36. So starting at 0, I go over to 12 and up to 36. One thing that's really kind of great about ratios is because these are all equivalent ratios, then what you should get here is a straight line. So you can see the points on the graph that we put there from our ordered pairs. If I connected all these points, they would be forming a straight line, and they should form a straight line because this relationship is said to be linear. It forms a line. If you get a set of points that aren't linear, then that probably means you made a mistake up here when you were filling out your ratio table, or you maybe perhaps mixed up your x and y when you were graphing. So it's a good way to check yourself. You should get a straight line. Some of you are going to learn, or if you don't learn it this year, you'll learn next year that because it not only forms a line, but it's also, if I extended this line, it would go through 0. And it's also said to be a proportional relationship, which we're going to talk about proportions in this chapter too. But that's just kind of a preview. All right, number 2. Mitch's car can drive 30 miles for every 1 gallon of gas it holds. Complete a rate table to show how far Mitch can drive on 2, 3, 4, and 5 gallons. Write the ordered pairs and then graph them. All right, so I have a ratio table here. I need to pull this time from my problem the ratio to use here. So it says Mitch can drive 30 miles for every 1 gallon. So that sounds like a ratio to me. I can see that there are, for every 1 gallon, I need to fill in how many miles? 30. All right, and then I have a set of values here to complete using this ratio right here. All right, so to get from 1 to 2, I multiply by 2. So I want to do the same thing down here. I'm going to multiply by 2. 30 times 2 is 60. And then I'm going to go back to 1 and try to get to 3. So to go from 1 to 3, I multiply by 3. 30 times 3 is 90. 1 times 4 is 4. So 30 times 4 is 120. Okay, and I'm doing this in my head, but let's pretend you don't know what that means. Then over to the side here, if you didn't know what that was, you would be doing 30 times 4. That's 0. 4 times 3 is 12. That's 120. Okay, 1 times 5 is 5. 30 times 5 is 150. And here's how I'm doing it in my head. What is 5 times 3? 15. And then I add the 0. Okay, 1 times 10 is 10. 30 times 10 is 300. Again, if you don't know that, you're multiplying. So 0, 0, start with the 0. 1 times 0 is 0. 1 times 3, and I add. Okay? 1 times 20 is 20, so 30 times 20, if you don't know that, multiply it. 0, 0, start with the 0. 2 times 0 is 0, 2 times 3 is 6, and then add. So 600. Once I have a completed rate table, I'm going to go ahead and write that as a set of ordered pairs. Again, I want to make sure my x and y, I'm using the right values for x and y. So I'm going to take a look at my graph first. I can see down here that the number of gallons is x. It's along the x-axis. So up here, number of gallons was first. It was listed first. So x is going to be with the number of gallons. And then my y-axis is the number of miles. Y is the number of miles. So I want to make sure that I list my ordered pair. When I list my ordered pairs, that y is second. Or I use these values second. Okay, so x and y, I've figured out what those are on my table. I know what they are on my graph. I'm ready to make my points. All right, so x is 1 and y is 30. So my first ordered pair is 130. When x is 2, y is 60. 3 and 90. 4, 120, 5, 150, 10, 300, 20, 600. Okay, so once I have a set of ordered pairs, I'm going to put them on the graph. Now, my graph doesn't go all the way out to 20, so I'm just going to do the first 5 here. So 130, I'm going to go start from the origin from 0. I'm going to go over to 1 and then up to 30. All right, so again, 20. These are going up by 10. I didn't list every number, but you know that 20, 30, 40 is how it would go. So I'm going to go over to 1, up to 30, and put my dot here. 260. So I go over to 2, up to 60. Over to 3, up to 90, would be between 80 and 100. 4, 120, so over to 4, up to 120 would be right there. And then 5, 150, so I'm going to go over to 5, up to, oops, ran out of room. So that would be 130, 140, so like about right there for 150. Again, if I want to double check that I have correct values, I want to make sure that these are forming a straight line, and they would be forming a straight line. So it looks like I used the correct equivalent ratios. And then just as a preview, because this line is passing through the origin, then these values are also said to be proportional, which we'll talk more about later. All right, so what did we do? We completed a table using scaling, or using our unit rate to get to the next number. And then we took those values from the ratio table and create ordered pairs. Make sure you get your X and your Y to match up with your X and Y on your graph. And then we use those ordered pairs in order to plot points on the graph. All right, see you soon.